While browsing for inspiration for a new video, I stumbled upon this site that won Award Site of the Day back in November 2023. Can't believe this one flew under my radar because the animations on it are seriously impressive. Among all the elements, one that really stood out to me was this sci-fi style, futuristic overlay navigation. It's a concept we haven't explored on this channel before, and it stood out right away for how well it blends design and functionality. You can see the interface features neatly divided segments with a slick flicker hover effect, but the most interesting part is this interactive joystick that you can drag around just like a game controller to select items from the menu. At first glance, it looked deceptively simple, but once I started building it, I realized there were quite a few tricky challenges under the hood. After spending a solid few hours on it, I managed to put together a working version that captures the feel of the original. I added that glitch-style reveal animation where the segments and content flicker into view. I also implemented the joystick interaction. You can hold and drag it around and the nearest segment becomes active as you move. And I even added sound effects to give it that immersive futuristic vibe. Not only that, it's fully configurable. This version shows 6 items, but you can easily add or remove links just by updating a single array. The layout recalculates segment angles dynamically in JavaScript based on how many items you include. If you'd like to see more award-winning experiences broken down and built from scratch, drop a like on the video and subscribe if you haven't already. And if you want to access the source code for this project, plus hundreds of other similar micro projects, along with a new website template every month, you can check out the Pro membership via the link in the description. Alright, let's get into it. Let's start setting up the structure for the navigation. First, we'll add a menu toggle button. This is just a simple trigger with 2 bars that will act as our hamburger icon. Next, we need the main overlay container, which will sit on top of everything when the menu is open. This is wrapped in a menu overlay div. Inside that, we'll add a background element using a div with the class name menu background. For now, we'll just use a placeholder image that I designed in Figma as the backdrop. Then, we'll add the top section of the overlay using menu overlay nav. Here we have got a close button, just 2 bars crossing each other. And next to it, we'll throw in a few dummy links. I'm using some placeholder icons here from Ion Icons. Similarly, at the bottom of the overlay, we have got the menu overlay footer. It includes a copyright notice and a few footer links. Again, just dummy items. Now the main part, inside the overlay, we'll drop in our circular menu container. This is where all the action happens. Right in the center, we'll add the joystick element. I'm using Ion Icons here again to give it that gaming style look with the main grid icon in the center and arrow on all 4 sides. We are only setting up the static structure here. The actual menu segments, the ones with labels and icons, will be generated dynamically using JavaScript. That way you can easily manage the links by editing a single array and everything gets positioned and calculated automatically. So we'll hook everything up with JavaScript later. For now, this sets up the visual layout of the interface. Let's move on to styling next. First, I'll import the fonts we'll be using for the links and the main interface text that needs a more digital mono-style look. Then, we'll start with a basic reset, setting margin and padding to 0, using box sizing set to border box to make sizing more predictable. For the body, we are using the font we just imported and giving it a black background to match the dark, futuristic theme. Then for all the paragraph and link elements, we'll set the text color to white, remove the default underline, make all text uppercase, and switch to the monospace fonts for the digital terminal style look. We'll also keep the font size small and consistent. Now for the menu toggle button, this is the circular button that appears at the bottom of the screen. We are absolutely positioning it, centering it horizontally, and pushing it slightly off the bottom. It has a rounded top edge to create that half circle dome shape with white background and black text. Inside it, we use flex layout to stack the 2 bars vertically with a small gap between them. Each hamburger bar is just a thin, white rectangle with a black background. These will form the hamburger icon. Next, we style the menu overlay. It's positioned to cover the entire screen, centered both vertically and horizontally, with no scroll and a high Z index so it sits on top of everything. Inside that, we have got the menu background, which covers the full area and uses a background image centered and scaled to cover the space. Now for the top and bottom overlay sections, menu overlay nav and menu overlay footer, both are positioned absolutely at the top and bottom, span the full width and have padding all around. They use flexbox to space items out. One side has the close button and the other has the icon or text links. The close button is a square container for our cross icon. Inside it, we have two bars that overlap diagonally. The bars are absolutely positioned and rotated, one at a positive angle and the other at the negative one, creating the X shape. The menu overlay items is a flex container used both in the nav and footer. It arranges links or icons in a row with consistent spacing between them. We also define styles for the icons in the nav bar to make them slightly larger than the default text size. Now we come to the circular menu, which is the container for the interactive joystick and the segments that will generate using JavaScript. It's positioned relative so that everything inside it can be absolutely positioned based on its dimensions. Inside it, we have the joystick, which sits perfectly at the center. It's a white circle with black icons, using flex layout to center everything inside. The entire joystick is draggable, and we have set the cursor to grab and disabled text selection to make it feel more interactive. The center icon class handles the icons placed around the joystick. We position each one absolutely up, down, left, right, and the main one in the center is made larger for visual emphasis. Now here is the important part. The actual clickable menu segments around the circle, the wedge-like slices, aren't in the HTML. We'll generate those dynamically using JavaScript, but we still need to define their styles here. Each menu segment is absolutely positioned and takes up the full circular area. It has a semi-transparent white background with a blur effect for that classy look, and it changes visually on hover. We also set a pointer cursor to indicate that it's clickable. Inside each segment, we'll place the segment content, which is centered inside the slice. This will contain an icon and a label. We are styling it as a vertical flex layout aligned to the center with slightly larger icons and bold text. The label uses the same main font but with a bit more weight and a softer casing. Then we define the hover effect for the segments. On hover, the background gets more intense and the blur shifts rapidly to create that glitchy flicker animation. We have added a keyframe animation called flicker hover that cycles through different levels of blur and opacity. Similarly, for the text inside the segment, we animate the color and transparency with another keyframe, content flicker hover. This makes the text flash between black and white to complete the glitch fill. Finally, we make sure the entire menu overlay is hidden by default, setting its opacity to 0 and pointer events to none. This keeps it out of view until the menu is toggled open with JavaScript. Alright, that wraps up the styling. Next, we'll jump into the JavaScript to handle dynamic generation, interactivity, and animations. First, we're importing GSAP. Next, we define the menu items array. This is where we list all the items that will appear around the circular menu. Each item here is an object with a label, an icon, and href. These are the links that will dynamically generate into clickable segments. This structure makes it easy to update the menu later. Just add or remove objects and everything else adjusts automatically. Then we define a few global state variables. Is open keeps track of whether the menu is currently open or closed. Is menu animating is a flag we'll use to avoid overlapping animations. It makes sure we don't trigger the menu toggle multiple times while it's mid-animation. And the responsive config is an object where we'll store the calculated dimensions for our circle layout based on the current screen size. Now we define a helper function called getResponsiveConfig. This calculates all the key values we'll need to lay out the segments properly. We first grab the current viewport width and height and check if the screen is under a certain size. If it is, we consider it mobile and size things down a bit. Then we calculate a max size by taking 90% of the smaller side, either the width or the height, so that the circular menu fits nicely regardless of orientation. Depending on whether the device is mobile or not, we assign a final menu size value. This is the full diameter of our circular menu. Center is just half of the total size. This gives us the X and Y center of the circle. Inner radius is how far in the inner arc of each segment starts, outer radius defines how far out each wedge stretches, and content radius is where we'll place the icon and label inside each segment. All of this math is going to be used when we generate our segments dynamically using trigonometry, basically to figure out where each wedge starts, ends, and where the content should sit inside it. That sets up the configuration. Next, we'll move on to building the menu layout dynamically when the page loads. Once the page is fully loaded, we hook into the DOM content loaded event to kick things off. The first thing we do is call getResponsiveConfig function and store its result in our global responsive config variable. This gives us all the calculated dimensions we need to build the circular menu based on the current screen size. Next, we grab some key DOM elements, the circular menu container, the joystick in the center, and the top and bottom overlay sections. We then set the width and height of the circular menu dynamically using the menu size we just calculated. This makes sure the layout scales nicely on different screen sizes without needing separate media queries. Now, before showing anything, we set some initial animation states using GSAP. We scale down the joystick to 0, basically hiding it until the menu is opened. Then we fade out both the nav and footer sections by setting their opacity to 0. Again, we'll animate these in when the menu opens. Now we dynamically generate the menu segments. We loop through the menu items array using for each method, and for each item, we call a function named createSegment. This function will return a fully styled segment slice for that menu item. We'll look at the logic for that function in the next step. After generating each segment, we add a mouse enter listener to it if the menu is currently open. Hovering over a segment plays a sound effect, just a nice interactive touch to give it a more immersive feel. Then we append this segment into the circular menu container, adding it to the DOM. After the loop finishes, we wire up the interactivity. We add a click listener to the menu toggle button, which will trigger the toggle menu function to open or close the menu. Same thing for the close button. We attach a click event listener to it and hook into the same toggle function. And finally, we call it initCenterDrag function, which sets up all the logic for the joystick interaction. We'll cover that part in a bit once the segments are in place. So by this point, our layout is responsive, the DOM is populated with the segments, all the initial animation states are set, and we are ready to start defining how many segments actually get built. Let's move on to the createSegment function next. It takes 3 arguments, the current item from our menu items array, its index, and the total number of items in the menu. First, we create a new anchor element. This will act as a clickable segment and assign it the class menu segment. Then we set its href to the link defined in the menu item. Next, we destructure a few key values from responsive config, menu size, center, inner radius, outer radius, and content radius. These were calculated earlier and will help us draw the wedge shape precisely using geometry. Next, we calculate angles. We divide the full 360 degrees by the total number of segments to get the angle per segment. Then, using the index, we calculate the starting angle of the current segment. We also find midpoint angle called center angle, which is where we'll place the icon and label. To give a slight padding between segments, we offset the start and end angles a bit inward by a small constant. Now comes the math part. We calculate coordinates for the inner and outer edges of the arc. We use basic trigonometry, cosine x and sine for y, and rotate the angles by -90 degrees so that the first segment starts from the top instead of the default right. We calculate 4 key points, the starting and ending positions of both the inner arc and the outer arc. These define the curved shape of the wedge. We also set a large arc flag. This is a value required by SVG arc commands. It tells the browser whether to draw the shorter or longer arc between 2 points. In our case, it's 1 if the angle spans more than half a circle, otherwise 0. Now we generate the actual wedge shape using a clip path. This creates a polygonal path that defines what part of the segment is visible. We are using SVG style path syntax to build it. We move to the inner start point, draw a line to the outer start, draw an arc along the outer radius, then comes back down to the inner end, and draw another arc along the inner radius to complete the shape. We apply this clip path to this segment and set its width and height to match the full menu size so everything stays aligned. Next, we position the content inside the segment. We calculate a coordinate that's partway between the center and the edge using content radius. Again, we use trigonometry to position this point at the center of the slice. Then we inject the inner HTML for this segment. It includes an ion icon and a label, both placed inside a segment content div. The inline styles place it exactly at the calculated coordinates and center it with a transform. And finally, we return the segment so it can be added into the DOM. So every time this function runs, we generate a perfectly positioned wedge with a label and an icon clipped to a custom shape and placed inside the circular layout. Up next, we'll handle the menu toggle animation logic, how the overlay opens, animates the segments in, and resets everything when closed. Let's walk through the toggle menu function. This handles the logic for opening and closing the menu overlay, and it's responsible for animating everything into and out of view. First, we add a safeguard right at the top. If the menu is already in the middle of animating, we just return early. This prevents rapid clicks or double triggers from breaking the animation state. Then we grab the main elements we'll be working with, the full menu overlay, all the menu segments, the central joystick, and the top and bottom sections, the nav and the footer. We also right away set is menu animating to true so that while the animation is running, no other interaction can interrupt it. Now we check if the menu is currently open. If it's not open, we set the flag to true and play a sound effect to signal the opening action. Then we animate the menu overlay in using GSAP. We fade it to its full opacity and enable pointer events so that we can now interact with anything inside it. We bring in the joystick next. We scale it up from 0 to its full size using a back out easing, which gives it a slightly bounce, elastic feel. Next, we fade in the nav and footer using a subtle flicker effect. We do this by animating their opacity up and down a few times using the repeat and yo-yo settings. It creates that glitchy transition we want before setting their final state to fully visible. Then comes the segment reveal. We loop through all the segments, but we shuffle the order randomly each time. This makes the animation feel more organic and unpredictable. Each segment is first hidden, then quickly animated in with the same flicker effect. We use a delay that increases with the segment's shuffled position, so the reveal happens progressively in a scattered fashion. And once the last one finishes animating, we reset the isMenu animating flag back to false. If the menu is already open, we set the flag to false and play the closing sound. We start by fading out the nav and footer, again using a quick flicker pattern for consistency. Then we scale down the joystick, reversing the same elastic animation from earlier. This gives it a nice collapsing motion. Now we animate the segments out in reverse. Just like the reveal, we randomly shuffle their order and fade them out one by one using a quick opacity toggle. Each segment gets its own slight delay, which makes the exit feel more dynamic. Finally, we fade out the entire overlay. Once that's done, we disable pointer events again and reset the isMenu animating flag to false, re-enabling interaction for the next toggle. So overall, this function controls the full lifecycle of the menu, handling sound, transitions, staggered reveals, and interaction locks to keep everything smooth and glitchy. Next, we'll look at how the joystick is made interactive and how it detects direction and highlights the right menu segment as you drag it around. Now let's set up the logic that powers the joystick. This happens inside the init center drag function. The idea is to make the joystick draggable, track its direction in real time, and highlight the corresponding segment around the circular menu as you move. We start by grabbing the joystick element from the DOM, then we define a few state variables. As dragging keeps track of whether the joystick is currently being moved, current X and current Y store the joystick's animated position, target X and target Y are the actual drag positions we are aiming for, an active segment helps us track which menu segment is currently being hovered or highlighted. Inside this function, we define an internal animate loop. This will run continuously using request animation frame to update the joystick's position every frame. Here is how the animation works. We smoothly interpolate current X and current Y toward target X and target Y using easing. We do this by moving a small percentage of the distance each frame. This creates a damped motion effect, basically a smooth trailing movement instead of a sharp snap. We then use GSAP to update the joystick's position by applying a transform with the current X and Y values. Now, if dragging is active and the joystick has moved far enough from the center past a minimum threshold, we calculate the angle of movement. We use a tangent tool to get the angle in radians, then convert it to degrees. We add 90 degrees to rotate the reference point from right to top and normalize the value so it always stays within a full 360 range. Then we divide the circle into equal slices based on the number of the menu items. Using floor, we figure out which segment this angle falls into and store its index. Once we know the index, we grab the corresponding segment element from the DOM. If it's different from the currently active segment, we clear any previous animations from the last one, then apply flicker animation to the new one, both to the segment itself and the inner content. We also raise its index to make sure it appears on top. This is just to make sure the backdrop filter we applied in CSS doesn't create a glow in the segments which are on the sides. We also play a soft interaction sound only if the menu is open. If the joystick moves back toward the center or stops moving, we remove the flicker effect and reset everything. That way, no segment stays highlighted unless you are actively aiming in a direction. At the end of the function, we call request animation frame again to loop the whole animation. This entire system gives the joystick that gamepad-like feel, smooth motion, direction-based targeting, and animated feedback when you aim at a segment. Next, we'll hook up the actual mouse events that control tracking, starting the interaction, tracking movement, and releasing when done. We start by adding a mouse down event listener to the joystick. When the user clicks on it, we set is dragging to true so the animation loop knows it should start tracking movement. We then get the bounding rectangle of the joystick element. This gives us its position on the screen. From that, we calculate the center point by taking the left offset plus half the width and top offset plus half the height. These two values give us the exact middle of the joystick in the screen coordinates. Then we define the drag function, which will run as the mouse moves. Inside that, we first make sure dragging is still active, then we calculate how far the pointer has moved from the joystick center. We do this by subtracting the center coordinates from the center mouse position and store the result as delta x and delta y. We then calculate the distance using the Pythagorean theorem, square both deltas, add them and take the square root. This tells us how far the joystick is being pulled from the center. To limit how far it can stretch visually, we set a maximum drag range. Here, we are just using a quarter of the joystick's base size as our limit. Now, based on the distance, we determine how far to actually move the joystick. If it's very close to the center, we reset it to 0, snapping it back to rest. If it's too far, we scale the deltas back proportionally so it never exceeds the max range. And if it's within range, we use the raw delta values as they are. This gives us smooth analog style movement with a nice resistance effect when you drag too far. We also call prevent default function to block unwanted default behavior like text selection while dragging. Next, we define the end drag function. This runs when the mouse is released. We stop the dragging by setting its dragging to false and reset the target position to 0. Then we remove the mouse move and mouse up listener so nothing keeps firing after the drag ends. After that, we register the mouse move and mouse up events on the document level. That way, the drag continues even if your cursor moves outside the joystick bounds. And finally, we trigger the animate function at the end to start the joystick's motion loop. This keeps running on every frame, following the user's movement and highlighting segments in real time. So that wraps up the entire joystick interaction from user input to directional feedback to animation sync. With this, the whole menu system is complete. It looks futuristic, feels responsive, and reacts to interaction just like a game controller. Hope you found the video helpful. See you in the next one.